Hello everyone, am I audible properly?
Yes,
Yes,
sir,
sir.
you're
Good
audible.
evening,
Okay,
sir.
okay.
Good evening, sir.
Good evening.
Good
So,
evening, sir.
good evening. So, have you gone through the content? So, I have uploaded the files in afternoon today.
Yes,
Uh, Please go through it. If you haven't done, maybe I'll take question on Tuesday. That is also fine. So, maybe today I'll quickly finish with the week 11 programming part also, right? But I want you read everything like 10 and 11 and come up with your doubts, right, on Tuesday. And next to next week Tuesday also I'll take the doubts, right, because we need only one day for finishing up with week 12, so we can do that. Okay. And for OP, maybe we'll be having sessions on Thursday, Friday, and Saturday it will be kind of doubt clearing. Okay, then let me share
sir,
my.
could you
Yeah.
please repeat what you said?
Which one? What you're saying?
Sir, what you said, could you please repeat?
I told Tuesday we'll try to take questions on threads, right? Week 10 and 11. So you read everything, 10 and 11, the theory part, and come up with your questions. And I'm already sharing the programs, right? Run all the programs because you have now Sunday and Monday completely. You can do all those things. And we are keeping Thursday and Friday for OPE preparation. So we'll have class on that. And Saturday it will be a kind of a doubt clearing. But I don't know. You have OP on Saturday also. In case it is there,
No, sir.
no, right?
There was no. Yes,
Okay,
sir.
okay, okay. Then it's fine. Okay, let me start then. Okay. So now today I'm going into mainly week 11 content. Okay. Okay. So first thing I want to uh, so last day what we have done, we have seen what is the problem we can face whenever we try to run the threads concurrently. So it could be some anomalies in our data, right? Because whenever a number of threads simultaneously wants to access a shared resource, right? So the output what I'll have means what I'll have in that resource, the state of the resource actually depends on the order in which threads access the shared resource. So which is may not be predictable. So that's a problematic part. So the solution we have designed, we can use the synchronized keyboard. So you can do it in two way. Either we can do a method synchronization or do a synchronized block. So today we'll see another kind of lock that calls a re-entrant lock, right? Which calls as a re-entrant lock. So it will look very similar uh, to what you have seen in the synchronization. However, the re-entrant locks are considered as a more powerful than synchronization. Whenever you mark a method as a synchronized, or you marked a block of code as a synchronized, so it do a synchronized access on that, means sequential access on that. Other than you don't have any control over it, right? It only guarantee the things will be accessed in a synchronized way. But what may happen, it may result in some situations which calls a deadlock situation, right? So try to understand, there are 2 points I'll discuss. One is starvation, another is called as a deadlock. Starvation is something whenever a thread trying to execute, but it is always preempted by somebody else, some other thread, so it is not getting a chance to execute at all. It is starving. We say it's starving for a very long time. But what is a date lock? Let us try to understand the situation. Suppose I have two resource. I have a printer, and you can see my screen, right? Hello, hello.
Yes, sir.
Okay. I have a scanner. So there are multiple threads which wants to do an operation that it will scan and document, it will send it to the printer, and printer will take the output. So now, suppose I am having just one instance of a printer, that means there is only one printer available for all the threads, and there is one instance of scanner which is available to all the threads. Now suppose I have number of threads which are working. Suppose I have a thread T1 and have a thread T2. Right. This is right now what I have. Now, what happened eventually? Thread 1 requested for a printer and the printer is allocated to it. Right. And T2 has requested for the scanner. Scanner is allocated for it. Now T1 wants to get access to the scanner also. So it is requesting to the scanner, okay, I want to access you. Similarly, T2 also sending a request to the printer. It say I want to access it. Now what will happen? To complete the specified job that I'll take a scan and print it, I need to get hold of both printer and scanner. Otherwise, I cannot do my job. Right? But in this situation, what happened? That I have requested for a scanner as a T1 which is held by T2, whereas T2 requested for a printer which is held by T1. Right? So this is a typical situation. We called it as a deadlock. The situation we call it as a deadlock. So if you look at the situation, it's basically you'll find a cycle in this graph. If you consider these are nodes T1, T2, scanner and printer. So if you closely look into it, you can find an loop. So if you follow my yellow color this thing, so see, it's actually creating a loop. Sorry, uh, 1 minute. So it actually creates a loop, right? See, it's basically a cycle, right? So whenever you have access and allocation happening in a way that each thread requests something which is held by somebody else, right? Then this kind of deadlock occur. So until unless one thread sacrifice itself, right? Other all the threads has to wait. Because T1 say I want a printer, T2 say I need a scanner, whereas printer is holded by one person and scanner is, so nobody is releasing it because he is hoping somebody will give it to me, the other resource. So it typically creates a situation which calls a deadlock. Now, in normal synchronization, this kind of situation may arise, right? But re-entrant lock let you lock resources individually, right? So I can have a number of lock on the resources, which let us have a fine control on this synchronization. So I'm not going into the details because detail is also professor not discussed, but only thing it gives you much finer control than normally you get it in a synchronized block or synchronized method. Now I want to show you how to use it. Right. Now I'll go for that race condition what we have seen. Some noise is coming. Somebody's this thing is open. Suresh, I think you're okay. So uh, I'll go for this counter example, I think. Okay. And I'll try to show you what is the problem. So this is again this counter example. Just forget about this thing. The first line for the timing I can put it in a comment. So I have a counter class. There is a counter. And every time what I do, I increment the counter. I print the thread name which is incrementing the counter and print the counter value. Then what I have done over here, I have created two threads, right? I've created the counter resource. So this is my shared resource, which is shared between two worker threads. Now what my workers are doing, they're basically calling this increment method, increment on the counter method, counter object, that is the resource. So it is nothing but both the threads are trying to increment the counter simultaneously. And how many times it is doing? It is trying to do it 5 times. So in a unsynchronized manner, if you want to see the output, so I have already discussed it. I'm not going in details. Last day also I have discussed this. So what is the name? Okay, re-entrant block only. So this program separately we have also done last day. So if you see, you can see the sequence is not okay. But this is somehow I'm getting is a synchronized output, right? Because I'm getting up to 10. So mostly it is getting in a correct way. Yeah, this is again came wrong. See, this part is wrong. This part is wrong. So that's why it's ended at 9. Okay, so this is also ended at 9. So you can see this having a genuine synchronization issues, right? So I want to use synchronization block. Sorry, don't want to use synchronization block, but I want to use this re-entrant lock. So re-entrant lock can be used similar to the synchronization block, but as I told, you can hold multiple locks. So I'm not using right now in this course or in this teaching right now because it is not covered by professor also, but it is possible to hold multiple locks. So it is very similar to that synchronization block. So I first generate a lock which is of type re-entrant lock type, right? Now what I do, I lock the lock whenever I go into the critical section. Then I do my job. Then finally, whenever I'm coming out of the critical section, I unlock this lock. So that happens. I lock it, then I execute my part, then unlock it, right? But typically what happens, like you can lock the lock multiple times in re-entrant lock, and you need to, until and unless you unlock it at the same number of time, nobody else can hold the thing. But it, I have kept it simple because that is also not to cover by the professor. It's a simple way. I have to create a re-entrant lock object. I need to lock it before accessing the critical section. So once I access it in the critical section, then I unlock it. Now, can you tell me why this unlock portion is in the finally block?
Like if there is some error, exception,
Yeah, then what will happen?
finally we'll always execute.
Yeah, the problem is suppose I lock, then I start executing, but I forget to unlock, or somewhere it is not unlocked. What will happen? The program will become stagnant, right? Nobody else can access my that section, critical section. So if you're putting it on the finally, then it makes sure anyhow it will be executed, right? So I want to make sure the unlock has to happen somehow, otherwise you cannot use it. So rest of the things are as usual. I want to show you the output. Please practice it, you may get it in the exam also. But as I told, most of the program like questions will be like what will be the possible output, right? Or which output is never possible, right? So if you use a re-entrant lock, this is not output, right? This is never possible. The sequence may be different, but ultimately you'll end up as 10.
Sir, before the lock, like why it was inconsistent? Like both, like
I,
one
I,
thread.
I have shown no, like if you don't do the counter having this issue, last day we have this register and all I have shown you.
Okay, it's like similar. Like
Haha. The same code only I have used. It is the same code, yesterday's code only, but the second version where I have a counter class separately. right? So again, this was the thing, right? I'll have a reminder section, okay, that can be accessed by multiple threads, right? Simultaneously, I don't have any problem. N number of threads can execute, but once one thread enter into this section, it basically first lock it. It's a nobody can enter now. Then again it will unlock it. Then somebody else will now enter into this, right? Again, this part can be executed simultaneously by all. I don't have a problem. But in this particular part, so as I given last day also example, it is like it is a room, right? I'm getting into it, then I'm locking it from inside, right? Now again, I need to make sure whenever I'm going out, I need to unlock it, right? Otherwise, other people also cannot enter.
Sir, in this the locked portion is that three lines, right? Like top you have written counter will be set as P R and then in the in the text, right?
Yes, yes, this is the problem thing I have shown, no?
That is only you have to lock this.
That is why I need to lock because counter is updated through the registers, right? Internally. So that I need to sync.
And this is what is happening in that
Yes,
example
yes,
counter.
exactly. Yeah, last day we have also done these things. We took a bigger loop there, 1,000 loop or something. Okay. I go for the next issue, which is little difficult to understand, but I'll make you understand it in with some analogy. Don't try to make it difficult or complicated because we won't ask very complicated question on it. We'll ask the questions which are required for understanding the typical programs, right? Because it's also having a lot of practical usability. So I can do synchronization block or synchronization method. I can do re-entrant block, but still I can have a problem, right? Which is due to this concurrency. What is that problem? The problem name is normally known as a producer consumer problem, right? So what is the typical problem? The problem could be explained in the book in many way, but we'll understand it in a very simple manner. Suppose I have a buffer. So this is a buffer. Suppose it's a 1 byte buffer, or it can store only one unit of information, one integer value, let it be. It store only one integer value, right? So there is a producer. Suppose I name it as a P, and there is a consumer. Up to this, is it clear to all what I have? I have a buffer where I can write an integer. I have a producer, which is an entity. There is a consumer. Okay. Now,
Yes.
a producer will produce something. What it produce? It basically writes an integer into this memory. Suppose it send a value 10. So 10 will be written over here. What consumer do? Consumer do just opposite thing. It read format. So what is the value? Rate on the wrote on the memory buffer. It will be read by the consumer, right? So I have a single memory inside which producer will write something and consumer will read it. So it is some kind of communication is happening between P and C. So P is sending some information to C, right? Which is happening through this buffer. Is it okay up to this?
Yes, sir.
Yes.
Okay. Now come to a situation that I have this memory, but what happened right now? The producer is there, consumer is there. Producer haven't written anything yet, not okay. But consumer already made the request to read. What will happen? It won't be able to read, so it has to wait, right? Because nothing is there. So one way to do this, if there is nothing, so read will return a false. Means read will not read anything. The call will terminate immediately. Getting my point? Another issue could happen that that there is a buffer. I have my producer, I have my consumer. So producer already has generated something. So 10 is already generated. Now producer again trying to generate a value. Now if producer write 20, before the 10 is consumed, what will happen? 10 will become overwritten. So I have to also prevent the operation that once the producer will write something, the consumer will consume it. Then only producer will able to write into it. Right? So there could be normal situation. Normal situation is producer will write something, consumer will consume it. Again it becomes empty. Then again producer will produce it, consumer will consume it. Okay. But exception situation is producer yet not written anything, but consumer first came starting to asking for reading the things. So read fails because there is nothing to read. Second thing may happen. So producer already generated something which is not consumed by the consumer. Now producer again trying to generate new information like producing another number. So I need to stop it because if I let it happen, then the actual item will be lost, which is there in the buffer. So consumer won't be able to consume it, right? So can you,
And the
yeah,
consumer can consume new, like new value, right?
but it won't be sync, right? That first information will be lost, right? So
Okay, the
that's a
first line.
lost update if you have done in DBMS. The 10 is updated, but consumer will never know it, right?
Like
Yes.
previous line. Yes.
Yes. So now, can you give me any example, real-time scenario of this producer-consumer problem? Suppose you have a parking area, right? Just in front of your house, just one parking car can be parked. Now think about your neighbors are also shared that parking, right? Now, if you park your car, until unless you take it out from that parking, nobody can utilize it, right? Now think about there are two parking areas and there are three neighbors trying to park into it. So first two neighbors park it, third person come. He trying to park, the park request will be failed immediately, right? So this could be one example. Second example, very common example, think about the transaction in bank. For deposit, I don't have a problem. But whenever I have a withdraw, suppose my money becomes zero or I don't have enough money to withdraw. Suppose I have only 10 rupees, I'm making a request to withdraw 11 or 12 rupees. So I cannot do it, right? So my request will be ignored. So let us see this normal situation, right? What happened in these cases? So my request will be rejected in that case. Okay. So I have simulated this exactly what I told this consumer and uh, producer problem. But this consuming and producing happened in a synchronized way. Nobody is interfering. So what I have over here, see, first it is my shared resource, which is my buffer, where I can have only one integer data. So producer will write into the data and consumer will read from the data. First I say data is not available. So available is false. So producer will write something, make the available true. Then just give me a moment, okay? Okay, sorry. Uh, am I audible? Hello.
Yes.
Okay,
Yes,
okay,
sir.
okay. Okay,
Yes.
so
So
I have a buffer for one integer, right? Which is a shared resource. Now my concept is producer will write an integer into it, then consumer will read the integer. So synchronous approach is I'll be like each integer written by the producer can be consumed by the consumer. So it will be in a same sequence, right? So way I do it, it is already synchronized. So way I do it, producer comes, he writes the data. So initially the available is false, right? Means data is not available. So if data is not available, means when the available is false, the producer do what? It writes something. Producer will write something. Then it will make available as a true so that now consumer can read it. So just it is printing that I have written this data. Now consumer will find now it became available became true. It will consume the data, again make available false. Now so that producer can come. Right. Now in this scenario, if producer come first, then the consumer comes. The things are fine. But what will happen if consumer come first, then producer comes? Then it could be a problem, right? So how do I do it? Because see, the problem is uh, it may happen both are basically checking the available simultaneously, right? Both the threads, the consumer and producer. So where is the problem? Let us see what I have. I have created a shared resource object. I made producer to run the shared resource. I made consumer to also run the shared resource, right? Then I have started the producer. I have started the consumer. Okay. Now let us see what the producer do and consumer do. So in the producer thread, producer is a thread, right? So it basically take the resource, then it try to write 5 times. It write first one, then waits consumer will consume one, then it writes two, it waits consumer will consume it. Because every time it is writing, it is making the available as a one. So when available is one, producer cannot produce. So again, consumer has to read it. Then it will reset the available as a false. Then so it should be an alternative, right? So if it is a correct way alternating thing, so it's supposed to be a synchronized. And every time producer will generate a one, consumer will consume one, then two, consumer will consume two, three, consumer will consume three, four, consumer will consume four. Now producer will produce five, consumer will consume five. So this is supposed to happen. So let us run this.
So what is that sleep like?
Huh?
Simulate production time. So
What is
sleep.
sleep? I told no last day, like
Oh,
I'm letting it to switch.
yeah.
I letting it to switch the things. It's the same concept here. I was telling you, right? Okay, so let us run and check it out how it is working. Where it happened? This was right. No, not this one. Oh, this was the code. Okay. Hmm. Java C. So see, this is appropriate, right? Produce one, consume one.
Sir,
Produce.
a wrong file have been run, sir.
Why?
Sir, you have compiled without and you have running wait.
Oh. Sorry. Okay. Uh-huh. Sorry. Okay. See now we got an unsynchronized thing, right? So I was thinking why. The 5 is not read. It is not produced also, consumed also. I again write it. See, now this 4 is missing, right, in the sequence. Again see 4 is missing. Again 4 is missing. Now 5 is missing. I make it more complicated.
So, but the pair is missing. Like, if it is not produced, then it does not consume it.
Yeah, let us try to analyze. I have changed a bit. I have made the consumer to run first. See, now 2 and 5 both are missing. So why these are missing in between? What is the reason? What could be the reason that many a time it is missing?
Sir, can you go to
Sir,
the
why 2 and 5 was missing?
Yeah, why? That is what I'm asking.
sir? Can you go to the code, sir?
Hmm. So this portion is important. Rest of the thing are mostly similar. Okay, I'm not fully explaining it to you in a correct, not correct. I won't say. I'll say rather. I am not giving you right now the complete explanation. I want you to analyze this. Okay, but I'm saying in a number of cases, the consumer is trying to consume the things before it is produced. So before it is produced, if it is trying to consume it, in that cases, what is happening? The request is getting failed. In a simple way, suppose in the first call, producer producer 1 and consumer also producer 1. Right? Now the consumer call come first before the producer. Right? So consumer call it. It checks the available. Available is false. So it do not enter into it. It just go out of the function. So that particular loop iteration will be skipped, right? The effect of the iteration.
Yes.
Getting my point. Then again you are calling. Suppose now this is set to a false, right? Or suppose it is set to right now true. In the time, producer got invoked. Now producer finding it as a true, so it only execute this, come out of the function. So in that particular iteration, the product, all the producer is called, but it is not produced any data because available is right now true. So many a time it is not happening. Think about a bank account, right? So suppose you have 10 rupees, you are requesting for 11 rupees. What will happen? Your request will be failed. It won't be fulfilled. Simple thing happening like that. But what if I want to sync? Sync in the sense, I want to withdraw 11 rupees only. I have 10 rupees. But I know at the same time, somebody is already adding 10 rupees in my account. Then what I want to wait so that that 10 rupees will added first. I'll have 20. Then I'll withdraw 11. Similarly, whenever consumer will come to consume it, right? It will check the data is available or not. If it's fine, data is not available, it will wait. It will wait. It will won't go out of the function. It will wait there. It will wait till the available will become true. then it will read it. Right. So these calls are wait and notify. These calls are,
So,
yes.
so in this it fails because like we are consuming two times before there is a produce in
No,
between.
no, there is no way I am waiting. If I'm going into the synchronization block, so if producer is going into the synchronization block, if it finds it is not available, it will produce. But if it is finding it is not available, sorry, it is already available, it do not produce, it just come out of the function. That's all. So it lets the consumer to consume it. Right. But now I want a different situation. I want, if data is not there, I'll wait just. So producer will produce something, then I'll go and read it. So that means now if in the producer and module, uh, in the producer, so suppose this is the producer and this is the consumer. So both are synchronized block. My thread enter into it, into the producer. Now, if it is find, if it find that this available available is false, then it will do what? It will execute and complete the things. But in case the thread enters, but it finds that available is true. What will happen? It will be kept in a queue. The thread will be kept in a waiting state. So previously we are waiting outside of the synchronization block, right? So if I say this thread is already executing, the producer thread is already executing, in that case what will happen? The consumer thread has to wait outside of the synchronization block. So once it is end up, then only the customer consumer will enter. Now when consumer is inside this block, producer has to wait. But now there is two level of waiting. Producer wait outside when consumer is already inside. Now once consumer is done, then producer enter. But still it checks the available. If available is false, then it start executing it immediately. But it still finds the available is false. Then again inside the synchronization block itself it will wait. It will let the C to enter into the synchronization block. Right. Now synchronization block, if C enters, C will make at the time of going out, it will make available is false. That ends the wait so that it can enter an execution. So the simple way, I enter into the synchronization block as a consumer. I check out data is available or not. If it is available, I'll consume it. There is no problem. But if it is not available, I won't left it. I'll wait. So for what I'll wait? So that I'll give a chance to producer to enter into the critical section, produce the data, and notify me in some way that I have already produced. Now you can proceed. Same thing happens as a producer. Once I want to produce, if I find the available is false, means there is no data available, I produce. There is no problem. But if I go for producing, but I find the data is still available, the old data, so I'll be waiting so that consumer will eat it. Then it will notify in some way that I have already done, right? So the thing way happens. So I go as a producer, I find it's still the old data is there, I'll wait. So consumer will do it, it will notify me that I have already written. So now again check the available, because available is supposed to be false now. So again I'll check, I'll find it false, then I'll start execution. So it's simple way. Suppose there is a plate, I keep a chocolate and you take out the chocolate from the plate. And the thing is created in a way, inside the plate I can have only one chocolate, right? So until and unless you consume the chocolate, I cannot keep another chocolate into it. on it, right? So what could be the problem? The problem is something that, suppose I haven't even given you the chocolate on the plate, you start checking the plate. If something is there, you want to eat, you give a eat request. So your eat request will be immediately rejected. Similarly, I have produced the chocolate, I have kept the chocolate. Again, I want to keep another chocolate. I cannot do it. My request will be rejected. But I don't want it. I want in a sync happen that I'll every time keep a chocolate, it will be eaten by you. Then only I'll create the next chocolate. Right? So there is a cake factory or question also there in the assignment, right? I'm producing a cake, you're eating a cake, something like that. So if it is eaten up only, I'll create another cake. See, in a practical scenario, it is also important because if you have an inventory, suppose inside inventory you can keep 10 machine. If already 10 machines are produced, you need to wait because somebody will purchase one machine, then only you can generate another machine, right? So real time, so you cannot say your customer that still there is no machine you can go. You will make him wait that I'll produce a machine, then you will purchase it, right? So this is a sync situation. So this happens in a wait and notify. Suppose in my go down there is no, I haven't produced any machine. So my customer comes and say send a request. I want a machine. I'll say wait. I'll say wait. Then I'll generate a machine. I'll create a machine. Then I'll notify him. Yes, I have created the machine. Now you can take it. Right. Now the same thing will happen. Now my go down is already filled. And if I want to again produce another machine, I'll be sent a wait. Now some consumer will consume a machine. I'll be notified that consumer already there is a place for a machine. You can do it. You're getting the concept. If you understand the concept, nothing is there in the code.
Yes, sir.
Okay.
So
So
then if you do like this, then no iteration will be skipped.
yeah, no iteration will be skipped. That is my idea. Okay.
So previously it was skipping because whenever it was that while loop
Yeah,
failed, it
request is
start
getting
trying.
rejected. Right? Request was getting rejected.
Okay, here it will wait.
Yeah. So what changes I have done? This is the synchronized code. See, every time I check available, so it say available, but I still wait, right? So see, producer comes, it finds available is true. Available is true means already some data is there. So I won't skip, rather I'll ask, I'll wait, right? The see, this is the infinite, it's a while loop, right? Still this available is true, it will be an infinite loop kind of a thing. Now, once my consumer will consume it, it will notify me. I'll check the available, then I'll get available equal to false. I'll come out of the loop. I'll produce it. I'll make available true. Okay. Then again I'll do notify. Now I'll notify whom? The consumer that I have already produced. You can come and eat it up. Right. Same thing happens in the consumer. If consumer find it unavailable, he do not leave it immediately. He will be waiting and every time checking the available got true or false. The same thing happens. The data produce and the moment it says a notify, I'll check it. I'll check it, it's available, then I'll proceed. So it's very logical. There is nothing, if you, whatever I talked about, different discussion, if you understand that, this is quite simple thing to understand. Code is only 3-4 lines, nothing else.
So when it is waiting, it will repeatedly check that while condition
Yes.
continuously.
See, it's perfectly synchronized, right?
Yes.
So even without notifying that, since it is checking the while condition available like again and again, like when
No,
once.
it's may not be. Because since it is a loop, this inside the loop itself you can have a small synchronization problem. So this notify makes sure the moment you notify it, immediately it should be checked.
No,
Okay.
I'm saying that if produces, then available will become true, and then automatically while not will be false. So
That is, I make want to make sure if there is somewhere it is waiting inside, the wait will be break and it will again go for this available state. Okay, you go through once. Okay, Tuesday again I'll take these questions. Maybe once you read it once, no, it will be more clear. So this is not difficult one, but I want you to read it. You keep the program, read the theory from the slides. This program, why I'm doing? Because there are very less program on the slides. So it is very important that you understand the program and compare it with the theory, right? So please, like tomorrow and day after tomorrow, you go through everything. 2 days are more than enough to go through everything. Compare the code, compare the slides. I hope that you have already done some part of the 10. Right, finish it up.
Yes.
Okay. Okay, so I have left with only one topic today. So I'll quickly finish it up. Today I won't do, I'll take a long session. I have something today. Uh, okay. Uh, there could be a problem with the collection types because collection types are not thread safe. What do you mean by thread safe? Suppose you have a collection called as an kind of a list, right? What may happen? Multiple threads try to read and write into the same collection at the same time. So as a result, what may happen? Well, when I'm reading it, my reading will be very much inconsistent. My reading could be very much share of the doc means which doc?
Sir, the one which you are using, sir.
Is this one?
Yes, sir. Yes.
I haven't shared it. I have to then save it. I haven't saved it.
Okay. No, sir. You can do it after the lecture, sir. No issues.
No, let me save it. Otherwise, I'll just close it. I'll just save it as a today so that I'll remember. Oh, what happened? No, it is there. Okay. Okay. So what happened? Like multiple threads, it's doing the concurrently reading, writing, and the collection types. So collection types are something like a buffer only. If some simultaneous read writing is happening, so the reading will be all inconsistent. So you want to prevent it, right? So actually, what happens in normal collections, right? If this synchronization issues happens, like whenever you're trying to read something from your collection, but at the same time, so think about a stack. You're trying to read from the stack, and somebody is simultaneously pushing a data. So the question will happen: if you read before the push, you'll get a old data, but if you read it after the push, so again it depends on sequence, like which happened first. So which is a risk condition. So I want to avoid it. So by default, Java cannot stop it, right? Java use a mechanism throwing exception. What is that? See, if Java finds more than one thread trying to access any collection simultaneously, it fires an exception. And that exception is called as a concurrent exception. Where it is? Okay, I'll show you. Okay. Uh, so let us look into the program. So I try to simulate that I want to read and write simultaneously on the map, which is a hash map. So you can take any other collection type also, it does not matter. Okay. So I have a hash map. So my key is an integer and value is a string. So first I put three values. So this writing do not have any problem because it is happening by the main thread only. No other threads are running at that point. Now this is again lambda implementation. We have already discussed. Again, I have given her one lambda because you need to be thorough with this part. Okay. So I have a writer thread. Writer thread basically writing fruits name, fruit 4, fruit 5, and fruit 5. Save 6. Right. Three fruits names. 4, 5, and 6. But reader thread trying to also read the map simultaneously. So this is how I'm making the synchronization problem. Now I'm making the reader thread and writer thread to run concurrently. And at the end, I try to print out what is finally happening in the map. So the problem is here the writer thread and reader thread are running on the same time. That means writing this is not a problem, but I'll find a problem writing this fruit 4, 5, and 6 because I'm trying to read at the same time. So this gives me a concurrency exception. So let us see what kind of output I supposed to get here. See, look out over here. It's a concurrent modification exception. So the moment you're trying to read it, another thread is trying to modify your collection, right? But for 5 and 6, the problem never happened. For writing 4, when you were writing 4 at the same time, some request came to read it, right? So that's why this came. So now, see, it's a different moment it happened. Right. Okay, but this is happening. So you take any kind of collection type, this problem can occur, right? So what is the way out? So there is another version of each of the collection type which calls a thread shape type. So if you are not using a thread, use the normal collections. Use the normal collections like your hash map, linked hash map, right? Then tree map or linked list, these things. But whenever you are going to use it and wants your threads to access your this thing in a concurrent manner, so you don't use it, rather go for a special kind of map. So there is a version called as a concurrent hash map. So all the collection you are having inside util, you are having a version in the util.concurrent, which is a thread safe version, which let you to do a synchronized access to the collection type. So it's exactly the same code. Only instead of hash map, I took a concurrent hash map. So you'll see the change. This overlap will never come. See, it's absolutely fine. This error you are not getting, right? Exception. Because it makes sure the reading and writing will happen in a mutual exclusive way. In a mutual exclusive way. Means when you are reading, you are not writing. When you are writing, you are not reading. So again, I repeat, inside util, you are having the standard collections, which you need to use if you are not using threads. But if you are using thread, it is better you go for util.concurrent because that gives a concurrent version. So on the top of any map, there will be a concurrent prefix. That means it could be accessed in a thread safe manner. Yes, what is the question?
Now, previously there was some exception like concurrent
Yeah, that is
modification.
what, because it was letting this reading and writing happen. So it
No,
was
that
not
error
happening.
is given by Java. We are not defining.
Yeah, it's given by the exception is thrown by Java because it was finding some synchronization issue that mutual exclusion is violated, right?
Yes, sir.
Okay,
So
like
we
this.
had done this same thing in iterator, sir, because one iterator is trying to read from the collection and another is making some modification to that collection. So that is why.
Yes, yes, exactly. You have to take a concurrent version, otherwise this kind of problem may happen, right? Yes, you're correct.
So both the errors are same. Like, yeah.
Yes, yes.
So that was because the same map object is being used like
Any
output.
collection, normal collection object, they are not thread safe. That's why you use a normal collection which is there in util, this problem may occur. May occur, again I say.
Yes. So in this case, it is happening because we are doing like map.put and that get is happening at the
See,
same time.
even it may not occur because it may happen you have completed all reading and writing separately, right?
Yeah. Yes.
You cannot guarantee what will happen, right? But
You know.
if you make it concurrent version, then it makes you confirm, guarantee that this overlapping won't happen, right? This mutual exclusion won't be violated. That's all.
This overlapping, we mean this put and get function.
That mutual exclusion won't be violated. Overlapping in the sense means it won't be interleaved. It will be in a mutual exclusive way. That's all.
And map is the shared resource here. Map.
Any data structure, I'm saying, which is
Yes.
there in util. So if you
So
are using with a thread, you should take it from the util.concurrent, the concurrent version of it. That's all.
yes,
Yes.
sir. So in this case, map is shared resource in this code.
In both the cases, it is shared resource. But in previously, it was not accessed in a mutual exclusive way. But here I make guarantee it will be accessed in a mutual exclusive way.
Yes.
Yes. Okay, that's all. I'm sharing the code right now. Please practice it. I'll take the questions on Tuesday. We need to finish it up. But what I'll try to do, what I'll try to do, um, next to next week also Tuesday, I'll have this threads, because I think even after Tuesday also you may have some doubt, because it's a conceptually difficult topic. So I want another day also. Okay, thank you everyone.
Thank you, sir.
So we'll meet again on Tuesday, and Thursday and Friday we'll have a lot of OPE, coding and all. Thanks for joining. Bye.
Okay, sir. Thank you.
Thank you.
Sir, you'll be sharing that
I'm
code.
sharing right now.